So in this class we're going to discuss about some of the problems which are regarded to DC generators and DC motors. So now we'll see about this problems. And sorry, an 8 pole DC generator has 960 armature conductors and a flux per pole of 20 milliweber. So you should calculate the EMF generated when running under 500 rpm if this armature is first lap connected and second is wave connected. So we need to calculate here. This is the given problem. So we want to calculate the EMF generated. So this is the problem given to you, so we need to find out. So write down the first given data according to the problem. So number of poles is equals to 8 and conductors, armature conductors is denoted with Z. Z is 960 and flux is given here. Flux is equals to 220 milliwebers, 20 into 10 to the power minus 3 webers, and the speed n is equals to 100 rpm. So we need to calculate the, so for first EMF generated in a lap winding. So what is the EMF equation of a DC generator? EG is equals to pi Z and P by 60A. So what is the pi value here? Substitute, and Z value 960 and P value 8 and 60 into what is meant by A? A is a parallel paths. For lap connected, A equals to 2. Number of parallel paths is equals to number of poles. Number of parallel paths is equals to number of poles. In case of wave connected windings, number of parallel paths is equals to 2. Okay. So here we want to substitute A equals to P. So where P is nothing but 8. So I'm substituting 8. 8 gets cancelled. So remaining. So we'll calculate, and so what is the value here? What is the EG value? So you should calculate and tell me what is the EG value. So EG value will get as 160 volts. So here we left the speed. So here there is a speed once, so you'll get EG value as 160 if you calculate that. Then this is the first bit completed, and we'll do again by replacing it with 2. So I'm writing here. So EG is equals to 5Z and P by 60A. So 20 into 10 to the power minus 3 into 960 into 8 into 500 divided by 60 into 2. So calculate it. So what is the value? You'll getting 640. Okay. So in this way you can do these kind of problems based on the EMF equation. So this problem is based on the EMF equation based problem. This problem is on generator EMF equation based problem. Okay, so this is kind of problems may ask in the examinations in order to find out EG equation. Okay, so this in this way you have to calculate. So this is about this particular equation, so I am erasing this. Okay, now we'll see the next problem. The next problem is based on the types of DC generators based problem. So types of generators based problem. That means in types of DC generators we will calculate the EG values. So in the same way we should calculate here. Okay, so I'm writing the problem. So a shunt generator delivers 500 amperes at 230 volts, and the resistance of the shunt field and armature are 50 ohms, and armature resistance is very less usually, so it is about 0.03 ohms respectively. So you need to calculate the generated EMF. Calculate the generated EMF. So given data, so you should note down the given data. So this is based on the shunt generator, so you need to draw the shunt generator first. So I am drawing the shunt generator. This is the shunt generator. So here armature resistance is given as RA is equals 0.03 ohms, and we need to calculate EG, and what is the load current here is given as generator delivers a current to the load, so this is nothing but IL. So load current is equals to 500 amperes here. The voltage, that means the load voltage is given as 230 volts here, and the resistance of the shunt field is 50 ohms is given, so you need to represent all this. Okay, so we want to calculate the EG, generated EMF. Now you should note down the given data. So IL is equals to 500 amperes, and voltage V is equals to 230 volts, and RA is given as 0.03 ohms, and RSH is equals to 50 ohms. So you need to calculate is EG. So what is the EG equation for a shunt generator? EG is equals to V plus IARA. So what is unknown here? IA. So you need to calculate IA. So in order to calculate IA, so IA is equals to IL plus ISH. So you need to calculate first ISH. So for that ISH is equals to V by RSH. This is the formula. So 230 by 50, what is the value? It's 4.6 amperes. So that means this ISH value is 4.6 now, and we need to calculate IA. So apply KCL, so that this is the expression we'll got. So we need to substitute 500 plus 4.6, which represents 504.6 amperes. This is the IA value. IA is equals to 504.6 amperes. Okay, so we have completed here. So now coming to here, you need to calculate EG. So what is the EG formula? EG is equals to V plus IARA. So what is the V here? 230. And what is IA? 504.6. And what is RA? 0.03. So you can substitute and find out the value. So what is the value here? 245.138 volts. So this is the EG value. In this way you can do this problem. Okay, so we have completed the EG value. Okay, so we have completed this one. Okay, in this way you can do the types of generators. This is based on the types of DC generators based on problem. This is based on the shunt generator. Okay, so in this way you can do this kind of problems. Okay, I hope that you will get understood by this. So in the next, so we'll see the next problem based on the losses and efficiency. Maybe it is not arresting. So the next problem is based on the losses and efficiency based problem. A shunt generator delivers 195 amperes at a terminal voltage of 250 volts. The armature resistance and field resistances are 0.02 ohms and 50 ohms respectively. So you need to calculate the iron and friction loss are given here. So the iron and friction losses are 950 watts. Find a EMF generated. B, copper losses. C, output of prime mover. D, electrical efficiency. So this is basically a shunt generator problem. So draw the shunt generator diagram first. So this is the shunt generator diagram. Okay, so this shunt generator is delivering a line load current of 195 amperes and at a terminal voltage of 250 volts, 250 volts. Okay, and next we are talking about armature resistance here given as 0.02 ohms, and field resistance RSH is given as 50 ohms, and iron and friction losses we cannot indicate here. Okay, so now we'll see the problem based on the given data. So here IL is given, here IL is 195 and terminal voltage 250, and RA value is 0.02 ohms and RSH value is 50 ohms, and iron and friction losses are given here. Those are nothing but mechanical losses and mechanical loss and iron loss. So both we are combinedly call it as a stray loss. Stray loss are given here. So first step is to calculate EMF generated. So EG is equals to V plus IRA. According to the data given, we need to calculate first IA. So then we need to calculate IA is equals to IL plus ISH. So in this ISH is unknown. So we need to calculate ISH is equals to V by RSH. So what is the value of V here? 250. 250 by RSH value 50. So what is the value here? 5. So ISH value 5 amperes. So what is the IL value given here? 195 plus 5, 200 amperes. So IA value is 200. So IA is equals to 200 amperes. Okay, so I need to substitute here EG by V. What is the V value here? 250. 250 plus what is the IA value? 200. What is the RA value? 0.02. So what is the value here? 254. 254 volts. This is the EG. So first bit is completed. Now we want to continue with this copper losses. So copper losses. So for B we want to know the copper loss. So for that we want to know the input minus so generator we are know the output power is an electrical power is V into IL. So what is the V value here? 250 into what is the IL value? 195. So if you multiply these two you'll get output power. So what is the output power? Sorry, so here there is no need of here. Again we will calculate this, but before going to this we can see here the copper loss are nothing but Ia square area. Copper loss is equals to Ia square Ra plus ISH square RSH. Okay, so what is the value of Ia? 200 whole square into Ra 0.02 plus what is the value of ISH? 5 square plus what is the value of RSH? 50. So this is the total copper loss. So you'll got the value as 800 plus 1250. So you'll got as 2050 watts. So this is about the copper loss. So we have completed the copper loss. Okay, so this is the armature copper loss and this is a shunt field copper loss. So both combinedly we are adding. So this is about the copper loss. And now we want to find out the output power of a prime mover. Output power means of a prime mover means input to the generator. Output of prime mover is equals to input of generator. So we can easily calculate here. So I'm erasing this. Okay, so output is equals to input is equals to output plus total losses. This is the equation. So what is the output power? You should calculate here. Output is equals to V into IL. So V is equals to 250 and IL is 195. So what is the value here? 48750 watts. So this is the output power. And next we should calculate input power. Input is equals to output plus total losses. So output is nothing but 48570 plus total losses are nothing but stellar loss plus copper loss 950 stellar loss plus 2050. So totally we will get input power. So the input power is equals to 51750 watts. Okay, this is about the input power. And now we can calculate the efficiency easily. I think you can calculate here. 48750 plus 950 plus 2050 51750. So we got the input value, input of the generator. Now we will calculate the efficiency. Summarizing this. So we have completed this. Now we wanted the efficiency. Efficiency means ratio of output power to percentage means ratio of output power to input power into 100. So we already got output value. So the output value is 4857750 and 51750. I think this is yes. So 48750 divided by 100, we get 94.2. So the efficiency is about 95.94.2. Yes, 94.2 efficiency. So this is, in this way we'll calculate this kind of losses and efficiency based problems of the generator. So I hope you got understood about this. Okay, thank you. So these are the problems based on the generator. Now we'll see problems on the motor. So now we'll see the problems on DC motor. So I'm erasing this. Okay. Okay, now we'll see problems, some of the problems based on the torque equation of DC motor. Okay, so in this class we'll see about a torque equation of a DC motor based problem. So calculate the value of torque established by the armature of a 4 pole 4 pole motor having 774 armature conductors, two paths in parallel, that means number of parallel paths is 2, and 24 milliwebers of flux per pole okay, and when the total armature current is 50 amperes 50. Okay, so we need to calculate the value of torque. So for this we need to note down the given data first. So given data is P equals to number of poles is 4 and Z is equals to here given as 774 and flux is given as 24 milliwebers. That means 24 into 10 to the power minus 3 webers, and here total armature current is given as 50 amperes. Okay, so we need to calculate the torque. So armature torque is equals to what is the expression 1 by 2 pi Z Ia into P by A. So this is the value. Here A is given as 2. Okay, so here I already mentioned 2 parallel paths. So now calculate 1 by 2 pi, flux value is given here 24 into 10 to the power minus 3, and Z value is given as 774, and what is the Ia value here 50, and what is the P value 4 by 2. So calculate this. So what is the value you're getting? This is 0.59159 into 24 into 10 to the power minus 3 into 774 into 50 into 2. So this is the value. So you need to calculate it. So you'll get 295.36 Newton meter. So in this way you can calculate this kind of these problems. So this is based on the torque equation. Okay. So this is based on this kind of problems on based on DC motors. I'm erasing this. So anyway, we'll see this another problem based on this torque. So the problem is a 6 pole DC generator, sorry, DC motor has a wave connected armature with 84 slots, 87 slots. Each slot containing 6 conductors the flux per pole is 20 milliwebers and the armature resistance of 0.13 ohm when the motor is connected to 240 volts supply and the armature draws a current of 80 amperes driving a load of 15 kilowatt. Calculate first bit speed, second bit armature torque, third bit shaft torque. So this is the problem. This is the problem given to you. So we need to calculate it. So I'm drawing the given data here. So this is a DC motor with wave connected armature. So here we are having poles is equals to 6 and the slots, that means number of slots is given here. Based on that we need to calculate the number of armature conductors. Here the conductors are 87 into 6, so it results, so what is the value here? 522. So z value here is 522. Why? Because 8 slots, 87 slots, so each slot is containing 6 conductors, so 87 into 6, so the total number of conductors is 522. And flux is given as 20 milliwebers, 20 into 10 to the power minus 3 webers. And the armature resistance is given as here 0.13 ohm, and the motor is connected to 240 volts DC supply. Okay, and the armature draws a current of 20 amp, 20 or 80, it is 80, it is 80. So IA value is 80 amperes. So the power value is given as 15, that is a load power, that is nothing but a load power, that is nothing but a output power. We can say the output power, the load power is mentioned here, that is the output power, output power. And we need to calculate the speed n value and armature torque TA and shaft torque TSH. So this is the given data and we need to require to calculate these parameters. So now I am erasing the problem. Okay, so we need to calculate first what is the speed equation. So speed, in order to calculate speed, first we need to calculate EB, then we will calculate easily n. Okay, so first you need to calculate EB, assuming that this is a shunt generator, as it is given here, as it is assuming it as a shunt generator. So EB is equals to V minus IARA. So here IA is given, V is given, so 80 into what is RA value, 0.13. so what is the EB value here? So EB value is 229.6. so this is the EB value, so we got the EB value. So now EB is equals to pi ZNP by 60A. From this we can calculate n value as n value is equals to 60 into A into EB by pi ZP. Okay, so here all the values are given and you need to substitute that 60 into what is the A value here. So here A is not mentioned or mentioned in the problem. So here wave connected, so the number of parallel paths is equals to 2. This is a wave connected. In the problem it is mentioned like that, wave connected. So it is A equals to 2 into EB value 229.6 divided by, what is the pi value here, 20 into 10 to the power minus 3 into Z is nothing but 522 into P is nothing but 6. Okay, so we need to calculate EB, so sorry N. So then value is obtained as 439.85, it is approximately equal to 440 rpm. So we got a first value, and the next torque is about armature torque. So this is the second bit. So 1 by 2 pi z ia into p by a. So all the values are given here, 0.559 into, and pi value you need to substitute here. Z value is 522 and ia value is 80 and p value is 6 by 2. So what is the value here? We got as 398.23, sorry, 39. So third bit is shaft torque. Shaft torque is a formula, remember this formula, 9.8 output by n. So the 9.55 is nothing but 60 by 2 pi, I think. So this problem comes from like this. So shaft torque is equals to output power into omega. So output power is nothing but shaft power. Shaft power by omega is nothing but uh, power is equals to torque into omega. This is not, power is equals to torque into omega, then torque equals to power by omega. So here omega is 2 pi n by 60, 2 pi n by 60. So 60 by 2 pi value is 9.55. So if you divided 60 by 2 pi, then it gives a value of output, the 9.55. 60 by this value is nothing but a 60 by 2 pi value. Okay, I have written here. So the 9.55 into output by n. So what is the output here? Output power is given here 15 kilowatt. Okay, so substitute that 9.55 into 15 into 10 to the power 3 divided by, what is the n value? You got as 440. Okay, so what is the value? 325.57 newton meters. So this is a shaft torque. In this way you can do the problem. Okay, this is the base problem. Okay, understood? Okay, okay, now I want to give a homework problem to you. A 4 pole 220 volts shunt motor has 550 lap wound conductors. It takes 32 amperes from the supply mains and develops output power of 5.595 kilowatt. The winding field winding takes 1 ampere. The armature resistances is 0.9 ohm, and the flux per pole is 30 milliwebers. Calculate speed, torque developed in the Newton meters. So these are the problem. This is a homework problem given to you. Okay, please note down. Okay, I'm erasing this. Okay. Okay, so now Swinburne's test based problem. Swinburne's test based problem. A 250 volts DC shunt motor takes 5 amperes at no load. The field resistance is 125, sorry, not 1.2, it's 125 ohms, and armature resistance is 0.5 ohms. Calculate the kilowatt output and efficiency when the motor takes 60 amperes on full load. So this is based on the Swinburne's test problem. So you need to calculate the efficiency and output. Okay, so now note down the given data. So here V is given as 250. So I'm writing here given data. Why? Because I will realize. So V is 250 and IL naught is equals to 5 amperes. IL naught is a no load current, and field resistance RSH is equals to 125 ohms, and armature resistance is 0.5 ohms. So you need to calculate output power and efficiency. Okay, these are the given data. So if you want load current at 60 amperes, so I'm erasing the problem. no load. First the solution is at no load. At no load, here you'll given as IL naught. So you need to calculate IA naught. IA naught, this is acting as a motor. So IL naught minus ISH. So ISH is equals to V by RSH. What is the value of V? 250 by RSH value 125. What is the value? 2 amperes. So 5 minus 2 is nothing but 3 amperes IA naught. So calculate armature copper loss. So which is nothing but IA naught square RA. So what is IA naught here? 3 whole square into RA value 0.5. So 4.5 watts, I think. So this is under no load case. Okay. Now we want total loss is equals to constant loss plus IA naught square RA. So which is equals to input power. Why? Because this is under no load case. So under no load there is no output power. Output power is 0. So input is equals to output plus total losses. So in this output is 0 means input is equals to total losses. So which is equals to WC plus IA square naught RA. Okay, so this is total losses. So we want the total losses. How can you calculate total losses? Means input power. So you need to calculate the input power. So the input power is equals to V into IL naught. So what is the V value here? 250 into IL naught is 5. So what is the value here? 125. 1250 watts. So input power is equals to, that means 1250 is equals to WC plus 4.5. So now we'll get a constant loss value here. So the constant loss value is, so I'm erasing this. Okay, now constant losses WC is equals to 1250 minus 4.5, which is nothing but 4.5. Okay, so this is the constant losses we'll got. Okay, so this is no doubt data from load. At load IL is equals to 60 amperes. So take IL is equals to 60 and ISH is equals to 5 amperes. We have already calculated. Now we'll calculate IA. IL minus ISH 55 amperes. So calculate armature copper loss, which is equals to IA square RA, which is equals to 55 square into 0.5. What is the value here? What is the value obtaining here? sorry, the IR value, ISH value is 2, not sorry, this value is 2. Is this value is 2 means this value is 58. This value is 58. So now tell me the value. 1682 watts. So this is about armature copper loss. Now calculate total losses. Total losses is equals to constant plus armature copper loss. So constant loss is 12545 plus armature copper loss is 12868. So the total value is 2927.5 watts. So total losses we obtain. So we want output power. Output is equals to input plus total losses. So we want a total losses means first we need to calculate input power. Input power is equals to V into IL. So this is 250 into 60. So what is the value? Input power. Input power is equals to 15,000. Okay. So now we need to substitute 15,000 plus 2927.5. What is the value here? Input minus total losses, so that means you need to calculate minus. Okay, so input is equals to output plus total losses, output is equals to input minus total losses. Okay, now we'll say 12072.5. okay, this is the output value. So the output and input is given here, so now we need to calculate the efficiency. The percentage efficiency is equals to output by input. So output value is 1272.5 divided by input. Input is 15,000 into 100. So we'll get efficiency as 80.5%. Okay. So in this way you can do the problem. So I will give a homework problem based on this. So is it clear so far? I think it is clear. Summarizing this. Okay, so now I will give the homework problem. Based on the Swinburne's test. A 220 volts DC shunt motor takes 3 amperes on no load. Field current is 1.0 amperes. Armature resistance is 0.3 ohm. Find the output and efficiency when armature current is 20 amperes.